We are in the hot rod era of electric cars. If you're doing it yourself, there's literally no standards out there. People are overvolting their motors until they explode. They're running their batteries in parallel when they should be in serial, making battery boxes out of plywood. Just like when moonshiners were tweaking their carburetors to gain a few horsepower. It's the Wild West right now for EVs. And that, more than anything, is what attracts me to making my own. The two goals of this video are to 1. Explain the basic components and the cost to EV swap a car, and 2. Wire up and bench test my Lancia Montecarlo. If you don't know much about EV conversions, then focus on the voiceover, as I'll be explaining it. If you do have some knowledge on EVs, then pay attention to the text callouts on screen. They'll provide more context to what I'm doing as I talk through the EV parts. And lastly, I'm not an electrical engineer, but I've watched enough YouTube and Googled enough stuff to be able to make a how-to video. And I know enough to be able to call people out in the comments section. So far, I've spent over $20,000 on the EV components for this build. And as I say that number out loud, I realize how much it is. I could probably bankroll Italy's GDP for a year with that much money. You can definitely spend more than I have on a conversion, but there's also a decent amount of wiggle room to cut down on the cost and spend less than I did. And I'll explain how. We're staying surface level on the explanations though. I'll tell you what the part is, what it replaces on a gas car, and how much you can expect to pay. I use the company EV West for the majority of my purchases. They're a reputable brand within the industry, somewhat local to me, and they'll work with and advise their customers on orders. That being said, there are a lot of companies out there, and I'm sure there are some cheaper options if you shop around. And if you really want to just raw dog a build, you can buy a wrecked Tesla for cheap and salvage all the parts. I might actually do this on my next build. Now the first question you're probably wondering is what motor should you get? Unlike gas cars though, the EV motor doesn't directly equal the horsepower. EV motors have a horsepower or kilowatt rating of what they're capable of, but it's your EV batteries that actually get it to that level. You can think of the batteries as kind of a combo of the fuel tank and a carburetor. What should really come first before the motor is what batteries and how many can you fit in your car. This is probably the area where technology is advancing the fastest, but a solid bet right now is using Tesla battery modules. If you're doing a small, light sports car like I am, 5 modules will be sufficient. I wouldn't go less than 4, and you can easily double the amount of batteries if you want. I went with 5 Tesla modules, and that ran me about $7,500 total. And this is definitely an area where you can cut costs. I went the expensive route since all available Tesla batteries are used. The ones I bought have the voltage verified at each cell. And 5 modules on my car should be giving me over 120 miles in range. Okay, so back to the motor. Once you know the battery configuration, you can find a motor that matches. I went with a 120 volt Hyper 9. My 5 Tesla batteries will be a combined 126 volts, so this motor is basically right there. This one cost me about $5,400, and that's pretty much the lowest you'll pay for a new motor, but you can find salvage ones off of EVs for just about any price. A good rule of thumb when picking a motor is to find something that matches or exceeds your vehicle's current horsepower. The next part is what's called the contactor box or junction box. This is where all your high voltage connections go. The contactors are kind of the main thing in here. They're like your starter. They bridge the connection in the high voltage batteries to the motor. The shunt allows you to measure the voltage just like a gas gauge would do. Anything that runs off of the high voltage batteries will also connect up in here. These contactors go for around $150 a piece, and the shunt's about $50, so you can do the math there. One of the things the contactor box connects to is your onboard charger, abbreviated to OBC. That box on the wall with the wire and plug that you put into your vehicle, technically isn't your charger. It's an electrical supply unit. The actual charger is going to be internal to the car. I paid about $600 for my charger, but last week I did something strange. I bought a second one. This means I can cut my charge time in half, and it will be on a switch so I can choose when I need it. Now, why wouldn't I want faster charging all the time? Well, charging puts a lot of wear on the batteries, so in times when I don't need it, I'll slow charge and help extend the life of these batteries. And surprisingly, another thing you need for your batteries is a battery management system called BMS. I think in the future this will be part of the OBC, but the BMS protects your batteries. It monitors them and can balance them, and it's kind of the brains of the batteries. I'm using a master control unit from Thunderstruck, which has a few extra features and costs $420. The last major component your car needs is a DC to DC converter, often called DCC. This takes voltage from your high volt batteries and brings it down to 12 volts for the rest of your car. It's basically your alternator and powers things like your lights and radio. And your lights and radio is why you still need a 12 volt battery. The one I'm using goes for $550. So total from just the parts talked about is over $15,000. And like I said at the top, I've already spent more than that. It's easy to spend more and there's ways to spend less, but this is a good ballpark price. That's pretty much all the major components you'll need, but by no means an exhaustive list of everything. This is more so meant to give you a ballpark idea and basic understanding. One of the last things to consider though is how you're going to get that EV power from the motor to the wheels of the car. If you're using a Tesla motor or something in a higher voltage range, you can send that power straight to the wheels. If you're running a smaller motor like I am, you'll want to attach it to a manual transmission. This is for two reasons. One, just like a gas car, I'll be able to stay in the power band of the motor. And two, I'll still get to shift an old sports car. Now let's see if after all this talk, I can get the motor to actually work. So here, I'm troubleshooting an issue with the main contactor. There's an A side and a B side, and I had them reversed. And I only found this out after hours of looking at everything. And unfortunately, I had to take apart the entire contactor box in order to fix it. And if you're wondering why everything's in the car, and I'm calling it a bench test, that's because none of it's finalized. All the wiring will be cleaned up and neat on final install. Okay, moment of truth. I got the throttle pedal in my right hand and some tape on the output shaft so you can see if it spins. Looks like we're in business. Hey Google, what time is it?
1:27 a.m.
You're goddamn right it is. Just in case you thought I was faking it or I got lucky, here it is again.